If you study Copenhagen Interpretation in the field of quantum mechanics, one theory is known as Copenhagen Interpretation. Actually, Copenhagen is the name of a city in Denmark. So there Niels Bohr and Werner Heisenberg, these two physicists gave their opinion about some principles of quantum mechanics. So here I have noted down few principles. Those are wave particle duality, next is uncertainty principle, next is observer effect, then comes probabilistic nature, then non-realism, and the last point is complementarity. So here in this video I am going to discuss the point complementarity. You know, particles means I am talking about fundamental particles at quantum level. The particles are electrons, neutrons, protons, etc. Quarks. So all these are fundamental particles. So in this case, means in the world of fundamental particles, both the nature, that is wave nature as well as particle nature, both are observed. But the point is, both the natures are not observed simultaneously. Whenever you are making attempt to observe one nature, then only that nature you can observe. You will be able to observe only that nature. Say, for example, you are going to observe the particle nature of electron. Then you will be able to see only the particle nature, not the wave-like nature. Whenever you are making an experimental setup to observe the one nature, the other nature, the information about the other nature is automatically lost. This happens in the world of quantum mechanics. If you use your knowledge, the logical knowledge, what you have learned in the field of classical physics, then there will be problem. You won't be able to match your logical knowledge acquired from the field of classical physics to apply in the field of quantum mechanics or quantum physics. Results are puzzling. Most of the results in quantum mechanics are puzzling. If you have studied to some extent this subject, then I think you should know this thing. So, here the point which is being discussed is complementarity. Complementarity means whenever one property, one aspect of the particle is observed, the information about the other is lost. You know the famous double-slit experiment. Two slits were used, and through the two slits, electrons were passed, and they fell on a screen. Okay. So on the screen, what was observed? Interference-like pattern was observed, and you know that interference pattern. This is the property of waves. That means, in that case, in the case of double-slit experiment, electrons were showing wave-like nature. But whenever you are trying to observe which electron passes through which slit, then you will be able to see only the particle nature of the electron. In that case, the interference pattern on the screen will disappear. Yes, of course, this is magical phenomena. This is quite puzzling, how this is happening in reality. How this is happening in reality, that is still not known. Researches are going on. But this happens. So, this was the point of discussion of today's video. The point complementarity is used for this. only one nature of the particle could be observed, not both the properties simultaneously could be observed. Okay. So this was these principles, means all these interpretations are known as Copenhagen interpretation. Not only this one, complementarity, but all the six here. Okay. So all the six principles together are known as Copenhagen interpretation. Once again, I want to mention the same thing, that Copenhagen is the name of a city situated in Denmark. Okay. There, in that city, all these things happened and formulated by Niels Bohr and Werner Heisenberg. You know, Heisenberg's uncertainty principle. So according to them, this is complementarity and the field of quantum mechanics. Okay, so this is the end of this video. Thank you. Thank you for watching this video.